Okay. Hope everybody's doing good. I survived the winter storm, as you can see. So that's an achievement, I think. And all I have to announce are three things, if I can find them. The first thing is that assignment 2 is now available on Canvas, as I'm sure some people have seen. I would recommend getting that accepted from GitHub Classroom as soon as possible, just so we can avoid all this stuff like we had with assignment 1. I don't think that's going to happen again. I tested it out. It seems to work fine, but you never know. Yeah, with GitHub Classroom, there that one issue I'm still waiting to hear it back from them about, but yeah, weird stuff can happen. Also, graded assignment 1 is due on Monday, so plan accordingly with your TAs. If you don't have a submission turned in, I just am going to go around and make sure and check in with everybody out who doesn't have a submission complete, just so we make sure and everybody's on a good track to get Unit 2 completed. And lastly, Magdalene, who's also a CEM here at Launch Code, she's going to join me for the liftoff Q&A that'll be on February 9th, which is going to be the next catch-up day. Oh, and if I didn't mention it, graded assignment 2 isn't due until the 13th, so not to worry about it. I just recommend making sure that you accept the assignment so we can make sure that we're good to go on that. And that is all I have for today. If you want to take it back over, Carrie.
Sure thing. All right. Let's see. I'm going to get my screen back up here and we'll get you guys into this Kahoot. Okay, you should have it again. It's only 8 questions tonight. Just covering some of the stuff from last class about objects and classes. Part 2. I'll give you guys a few seconds here, but then I'm going to get it started. We can turn the sound back on. Because the music is fun. All right. Everybody keep joining. I'm going to get this started. You can still join though. All right, question 1. True or false? The final keyword is used to prevent a value from being overwritten. That is true. Great job, everybody. All right. Folks are fast. All right. True or false? It is possible to declare a final field without initializing a value as long as you give a value later with a setter. Trick question. It is possible to declare a final field without initializing a value, but you have to give it the value in the constructor. You can't do it with a setter. Final fields should not have setters. All right. Which type of field stores a single shared value at the class level? All right, static, you got it. Okay. Next question, multi-select. Which two keywords must be used to declare a true constant? Great. Yeah, final keeps it from being overwritten and static stores it at the class level so that it's the same for all objects. Great. Okay. Question 5, multi-select. Which is not true about the toString method? Music is very dramatic. All right, 3 more seconds. All right, I completely screwed this up apparently. So, which is not true. Yeah, wow. I'm so sorry, guys. I marked the wrong 2 answers. I must have changed my mind about whether I was going to ask you which was true or which was not true. Yeah, so it's actually the opposite, and I am sorry about that. The override annotation is not required, but it is recommended. It is required in some circumstances, but not always. And you can print the just the object and it calls it implicitly, so it's not true that you have to call it explicitly. I am so sorry. You know. True or false? The default equals method actually checks identity of 2 objects of a class, not equality. That's true. Good job. All right, true or false? If a method uses instance fields with unique values for each object of the class, it can be a method. Okay, it looks like that tripped some folks up. Yeah, that's false. Because if each field as an instance field is going to have a different value for each object of the class, then the method needs to be an instance method as well, so that it can have a different outcome every single time. But a static method is going to be held at the class level, and so you don't want to involve different values for each object of the class. You want to call it directly on the class, and so those values don't matter. Okay, one more question. Which is not true about a custom equals method? I give you plenty of time on this one. All right, 15 seconds left for anybody who's still deciding. Okay. Yeah, looks like the majority got it. So yeah, this is kind of a tricky one because as you might remember from last week's lecture, or sorry, last class's lecture, the equals method can be quite involved when you're customizing it because you have to think about a lot of different things. And you do want to check first to see if the two items actually have the same identity or if the item being passed in is null, because you can immediately return true in the first case or false in the second case if those are true before even having any more logic after that. But you definitely do want to check the class before you cast it. You do get to decide what values are being required for comparison, which is why it's so great to be able to customize it. And the argument is declared as being an object type, which is then why you later have to cast it to be of the class. Okay. All right, third place, DJ Spaghetti Legs, love it. Student. First place is Marcus. Good job, Marcus. In spite of me screwing up, I am so sorry about that. All right. So let's move on and get started with lecture. We'll talk about a completely new topic, which is unit testing. I need to get my other thing up here. Hold, please. Here we go. All right, so typical class tonight, we'll do lecture and studio and come back for studio review at the end. Colin mentioned this already, but the deadline now for grade assignment 1 is Monday. And yeah, you've got a little bit more time on grade assignment 2, so go ahead and accept it now and then work on it over the next couple of weeks. Unit testing with JUnit is what we're going to talk about tonight. We'll talk about the principles behind unit testing, which we've covered a little bit, before because we did Jasmine in Unit 1, but we'll revisit some of that. Talk about JUnit setup specifically, what annotations are, the common assertion methods that come with JUnit, import statements, and then how to run the tests in IntelliJ. So general principles. Tests are important. You can have a really well-established code base, that your product has been around for a while, it's working, it's running smoothly, but it is a living organism because, the product folks will come and say, hey, we have got some new business requirements and we need you to make some changes. And you go in and you refactor the code and then suddenly, other things might break as a result unintentionally, not because you didn't know what you were doing, but because there's a lot going on and things are connected. So having tests really helps catch those things so that you can fix them in the process of refactoring. Good code coverage with automated tests catches those future errors. That's pretty much what I just said. But the concept of code coverage essentially means that every test you run, whatever methods are called in the process of that test running, that code is considered covered. And so you can kind of, and you can get reports on this when you run your tests sometimes and see like, do I still have areas that I have not covered the code? Do I need to write more tests? It's very helpful to kind of get a sense of how well your code overall has been covered and checked. Okay, tests also specify the expected behavior and outcomes and are therefore an excellent source of documentation. And we've talked about that before too. And I'm going to kind of show you tonight some ways with JUnit that you can make that, really good. Like you use some of the benefits of the way that it allows you to write the assertion methods to make better documentation. Okay, so good tests are deterministic. The test should produce the exact same result every single time. And if it's unstable, it's not useful. And in my experience, most of the time when I've come up with unstable testing, it's been in the process of doing like end-to-end testing where I'm calling APIs and it's asynchronous and you don't always know how long it's going to take for something to come back, and the test, will time out, after a certain amount of time or whatever. And that can cause a test to be unstable. When you're doing unit testing, that comes up a little bit less often. But yeah, you want your test to be stable. The test should definitely be relevant. You want to group them together by related class and function, keep them organized, and there's a method to the madness. And they need to be meaningful. There's no point in testing parts of the code like, getters and setters, right? Because you really are, unless you've customized them, they're their server purpose, they do their job, they're fine. Something else that you are testing is going to break if it depends on one of them. So just as important as knowing the right syntax is knowing how to approach this, right? How do you decide what you're going to test, how you want to go about it, what kind of things that you need to put in place. That is a learned skill. You build it with experience. I have had, different jobs where I've worked with different code, different languages, different testing suites. And, sometimes I was working like pair programming with a senior developer and they were kind of walking me through it, and I learned a lot about how to approach it. And I feel pretty confident these days going in and writing them myself, but it does take practice. But you might remember, we've talked about before, the idea of having positive cases, how you like the right outcomes if things work like they're supposed to. Negative cases, if something comes out, like if in the case of a Boolean, if it comes out to false, or maybe some other considerations that you would consider negative. And then edge cases, stuff that might come up from time to time, better to go ahead and have a test just in case it does. Thinking all of that through. And, you can ask, what test data do I need? Is it reusable? Or am I going to need to declare something new with every single test? So all these things kind of just, you have to, think about them as you're going about it. And one very helpful thing that they include in this unit is this idea of the AAA pattern. So you can kind of use this pattern when you write tests, and it helps you think it through. You arrange the variables that your test requires. Sometimes we call, this test data or dummy data, what expected values you might have. You act on the methods that your test requires. So you go and get the actual values that come back from whatever code you're testing. And then you assert a comparison of expected and actual values, or maybe it's some sort of Boolean condition that proves your code works. And the test, if it comes back true, then the test passes and your code is good. And if it is false, the test fails, and then you've got a problem. So this example here, you guys know I love my little, add, N1 and N2 example, because it's, very, very simple way to show things. So, here again, we've got a class called arithmetic. It has this, add method that is part of it. And I'm going to create an object of the arithmetic class called adder. And I'm going to, go ahead and arrange some variables for some test data. I'm going to call N13 and N25. And I'm going to say that my expected sum is going to be 8, because I know that 3 plus 5 is 8. So, simple values, doesn't have to be fancy. And then I'll act. I will go and find out, what do I think the actual, what is the actual thing that's going to come back? And so I, call the method on this object or this class, pass in those values, and then it stores whatever comes back. And then the assertion method compares the two, right? Compare the expected value against the actual value. So this is like the most basic way to do this. You don't have to do it all in, in multiple lines the way that I've done, but I'm doing it for the sake of being really clear about the thought process in all of this. So I'm going to continue to kind of do that tonight with some of the live coding that we do later. Okay, let's see. Got to get it to move on. Here we go. Yeah, so setting up JUnit, there's dependencies. Your chapter walks you through this, but I'm going to touch on it briefly. There are 2 jar files, Java archive files, that will make this library available to your application And they're in this lib folder up here. So this is a clone of the Java Web Dev exercises repo that you guys have been using for a lot of your stuff this unit. And you can see here that if you right click on one of them and come down and say add as library, it pops this up. And I'm not sure why the name is missing, but anyway, I think it was supposed to pre-fill it. Anyway, you just make sure you're adding it to the, the module you intend to, and you say, okay, and it adds it. And then you can start using it to write your tests. And you just have to do it with both of those. But I do want to, so there's these two files that Launch Code provides in their code for this particular repo, and then also for your studio tonight, it'll be this way as well. But for tonight, you aren't going to have to add them. They're already added because they've given you a little bit of starter code. But I do want to point out that my lecture example repo that I'm going to be working with tonight actually uses a Maven build. So the setup is a little bit different. And I'll show you when we get there. But this is, the way the launch code walked you through it, just so that you could, practice it for the way that they had things set up. Okay, so the file structure of the test files themselves, you typically keep the classes in a main folder, and then you keep your tests separately in a test folder. And you'll have a corresponding test class for each class. And the most common convention is just to stick the word test on the end of the file name so that they correspond, very obviously. So in this example here, the first one, you've got, a class named car, and then you've got car test in the test folder that corresponds to it. But different builds have different file structures. So, but as long as they're parallel, it works. So you can see in this second example, which is from my lecture examples we're doing tonight, I've got, in the source folder, there's a main folder and there's a test folder. Inside the main folder, there's Java, and then there's all these packages for the different class examples. And for tonight, I've got, we're going to be revisiting another version of our book and library classes. And so I've got all of those up there in the main folder, but down in the test folder, I followed that same structure of test Java class 5, and it's parallel with the other one. And so then these files, automatically correspond to the classes they're named after. Somebody have a question, or are you retracting your question? Okay, so let's talk about annotations. You want to make sure that the compiler knows what is what when you're writing your methods for your tests. So the most common annotations are test. You need to put that on the top of every single test that you write, but you can also have before that will annotate a method that should run before every test runs. And the reason this can be important is because you end up having sometimes you might create an object and say, I want to use this test data. And then different tests perform different operations on that object, but then that's mutating it, right? It's changing it. And these tests are run in random order. So if they run in a different order than you wrote them in, which they probably will, then things might not behave the way that you expect, and they can become unstable. So in this case, you can see I've created, this example where the two books, and I have them declared outside of this, but then in here is where I actually instantiate new books, instantiate a new library. So this is obviously my library test class. And that way, every single time I run a test, no matter what order they run in, it's going to go get a brand new book 1, book 2 in a library and start fresh. So that's important, depending on how you design your tests and what you need to do. And then, of course, there's also an after that is used a little less often. In the type of circumstances we're doing, we don't really need it. It's more like if you are, I see your book gives a good example. It's like opening and closing. I cannot remember what it is now, but yeah, if you have some sort of connection that you're making or some other thing there, you need to actually like shut it down because you're actually reaching out. That's when after can be really useful. So we're going to practice all of this in a second, but I'm running through the slides now so that we can just, to give you the highlights, and then we'll get in and actually practice it. So the assertion methods you will see the most are assert equals to compare two values, assert true to have some sort of conditional expression evaluate to true, assert false, which is the opposite of that. And then assert not null can be handy sometimes. If you expect a value is to be null, or if you want to, if you want to test what happens when it is null, or you want to make sure that it's not null. I guess I should write that a little better. But you can see here in this example, I've written this, and you might see something extra here, and I'm going to talk about this. I mentioned earlier that for better documentation, there's a way to do this. Every single one of these assertion methods has an alternate constructor. So you know about overloaded constructors, right? You can actually pass in a string as the first argument and then give the expected and actual arguments after that. And it gives you a way to have a little sentence that describes much better exactly what that thing is doing. And then you don't have to depend so much on the name of the method as being some sort of meaningful representation. I mean, it should still be meaningful and unique, but you can say a lot more and be a lot more detailed if you use a string. And so I am in the habit of using all three in this case. So assert equals, I'll actually give that, specification, and then give the expected value, and then the actual returned value from calling the method. So we'll practice that tonight as we go through. And I recommend that as a best practice. Grant, you got a question?
Yeah, so these are all within the @test annotation. Like you're doing the spec, expected, and actual in there. Is that something that you could also do within the before block, or what's going on?
Because you want them to be unique to each test. They're really only meaningful if they're very specific to what it is you're testing for that test.
Gotcha, thank you.
Yeah. The only thing you'll put outside is like reusable test data usually. Okay. So import statements, there are multiple types of imports, and you want to make sure you've got them at the top. Sometimes as you're typing, it'll suggest it. You guys have seen that in other cases, right? And you can just tab over and it'll, pop it up there for you. But if not, you can always go in and, use these types of statements to make sure they're at the top. So there's any annotations you need. You'll see in the first example here, there's org.JUnit.test for the test annotation, but the second one has both before and test. Any assertion methods you need. It's fairly safe with the assert class to be able to just use that asterisk though, and then you don't have to list them one by one. And it's not too memory heavy to do that. And then, if you are using something that, like the way that LaunchCode has arranged their code, you might need to import your classes as well, because it's in a separate package. Maven actually connects them in a way that you don't have to do that. Okay, so the last thing is just how to run the tests in IntelliJ. You can, run them all at once from a file. You can run just a single test, which is useful sometimes if you have a lot of tests in a file. It can take time depending on what they're trying to do. And so it can be helpful sometimes to just run one or just isolate the output, especially. Once you've run it from the left side, it's available in that drop down up at the top right of run configurations, like I've kind of shown you here. But you do have to run it typically from here first. And there's, I'm sure, other ways to do it. This is probably the most straightforward way for while you're just working in the code. But then you see the test results below. So this is an example of where I've got 4 tests passing and 1 failing. And then you get, in the console itself, you get, the error message. So yeah, left side is the files, the test in the order that they're running. And the right side is any logs that come out as a result of, standard .out print line. And then any error messages from the failure. And I will point out here that you see this first red line here where it says find book returns -1 when book has not been added. That would not be there if I had not included that first parameter in my assertion method, that thing that I'm calling spec, that's the message. So that's one of the reasons I like to do it, is because it's also useful when it comes up in error messages. It's a lot easier to immediately know exactly which one it's referring to. Aside from the fact that it does tell you the name of it, you get the full picture when you can read more information. So it's helpful. Okay, so let's actually go over then and look at all of this. We have quite a lot that we're going to do, but it's going to be good because I want to be able to kind of give you some different scenarios and help you guys think all of this through. So I have written, you know, somewhat varied versions of what we kind of where we picked up from last class on these, you know, book and library and utils classes, along with the main class, but we're not really going to need to run that because we're just interested in running the tests tonight. So, you know, we're going to go over into these test files and we're going to write tests that will, you know, cover the code that is in each of these classes. I want to start out with utils because if you remember, there's just this one little utility function in here, this method, get initials, right? Where we just give it a name and it spits out the initials and we use it in the book class. Now, I have worked places where they didn't really bother to write tests for the utility functions. The reason being because if those utility functions are being called by something else that is being tested, it's covered automatically because it's being run as a result of, you know, being used elsewhere. So there's an argument to be made for that. However, this is a very simple test that I thought it was a good way to start. So we are going to go ahead and start with this one. So we've got this thing, you know, as you can see, we give it a string that's a full name and it returns, you know, the initials to us as a string to uppercase. So we want to make sure our test data is going to reflect all of that. So just one to do for this one, since we only have one utility function in there, method, excuse me. So I'm going to use at test, you can see I've already got the import statement up here for it. So we're good there. And then tests are public void. That's all you need. And then I'll give it, you know, a useful name. So, you know, something like initials returned from full name is, you know, not too terribly long. And then if I want to be more detailed, this is where, you know, I can kind of say, okay, I'm going to write a spec that is a little bit more informational. Returns initials only when given a full name. And then I might say, okay, so what's my expected value going to be? I'm planning to feed it the name Grace Hopper. So I'm expecting to get capital G, capital H back. So then I can say, okay, what's my actual going to be? And this is where I actually, you know, act on the method that exists in the class that I'm testing. So I can just call utils and, oh, by the way, utils. Notice that because I have used this in both class 4 and class 5 packages, it's offering me, you know, options. So I'm just going to tab over because the first one is the one I want. It's the class 5 one, not the class 4 one, right? If you guys end up coming back and live coding this along with the video later, just keep that in mind. You want to just make sure you get the ones from class 5 and not class 4. Okay, utils.get initials, and then I'm going to give it Grace Hopper. And then I could do my assertion, the very last part. And I'm going to do assert equals. I'm going to give it the spec at first so that I'll have that message in there, give it the expected, and give it the actual. And then I can run it. So I'm going to actually run it from the top of the class here. I'm going to right click and say run utils test. And then down here, yeah, it runs it, it passes. And so it just says process finished with exit code 0, which means everything's cool. You know, could I have written this, you know, wow, that was not what I meant to do at all. Okay, there we go. I could have written assert equals and, you know, message goes here and then, you know, GH, and then I could have done the utils dot get initials Grace Hopper. Oh my goodness, can't type it tonight apparently. I could have done all of that in here, and of course this message is quite long, so if I'd actually put in the real message, you can see that gets really long really fast, right? And it doesn't make it super clear exactly what it is that I was laying out as a thought process. So that is exactly why, instead of doing that, I'm going to do it with a generic, using each of these generically, but then specify them ahead. Does that make sense? And just kind of help you guys see, what belongs to what. Okay, so that's it for that one. Let's move over to book. So the book class has a lot going on. And so we're going to definitely need some test data to work with. Then we can make it reusable. As I showed you when I was talking about it in the slides, we can actually have something where we use this before method that's going to instantiate a new book every single time we need it, because it'll do it before each test, no matter what test, what order the tests run in. But first, we just want to declare them. So I'm going to say it's a class 5 book, and I'll call it book 1. And I can get my notes here. I can make this easier on myself. All right, we're going to go with a new book called Hidden Figures by Margaret Lee Shetterly with 271 pages. And then we'll do another one, book 2, because ultimately we're going to want to be able to test the second constructor of this class, which, as you may remember, allows you to give a title and an author without giving the number of pages. And we want to test that it still sets it the way we expect it to. So I said that we were going to declare it and not initialize it. And look at that, I initialized it. So sorry about that, guys. Okay. So this is where we actually are going to do this. We will declare a before block. And then say public void, and I'll just call it, create test data. Make it obvious what it is. And then I can say book 1, which already exists. And that was supposed to be book 2. So book 1, and then I'll get the right thing from my clipboard. There we go. Okay. So now we have our books actually initialized, and this will run before every single test. And we'll have a fresh book 1, fresh book 2 that have not been operated on, right? They'll just have whatever was given at the time the constructor ran, and that's it. And then we know that it'll be stable no matter what order the tests run in. Okay, so let's start by testing our constructors just to make sure that they correctly set the values that they're supposed to. So I'm going to start with public void, and we'll call it first constructor sets title, since that's what we're testing specifically for. And I'm going to have a spec that is, constructor sets title. And I'll have an expected string, and we're going to say we know that we expect this title to be Hidden Figures if we use book 1. And so for the actual, that's exactly what I'll do, is say I want, book 1, and I'm going to go and I'm going to get the title and just check and see if those two are equal. So we'll assert equals and give it the message, and then expected, and then actual. Okay. So let's go ahead and run things now just with this one test, and I'll run it. It's going to jump on me. Here we go. There we go. Run book test. All right, and it ran the first thing and it passed. So we now know that the constructor is definitely setting the title when it runs, and then when we go and we get the title, after it's been initialized before the test runs here in the before block, it has indeed been set to Hidden Figures. So you're using dummy data. You just come up with something that works, and it doesn't have to be complicated. And you're just tapping into your actual class when you go to get that actual value to check the real code using the fake data, and then just making sure that it is what you think it's going to be. And this is it. This is the process. So we can essentially copy this down for the next one. We're going to say this one sets the author, and we expect the author to be slowly, shutterly. And this one will be get author, because we have a getter for that as well. And then, you know, this still works because we're using these variables. So I'm going to run it again. And it passes. So you'll notice I'm not, you know, practicing any test-driven development right now because all this code already exists. But sometimes this happens where you actually, you know, come in. I mean, the last company I worked for, one of the questions I asked in an interview was, you know, okay, so what kind of like, you know, automated testing do they do? And they got these sheepish look on their faces. They're like, well, we know we need to implement that. And so it wasn't shortly after I started working there that we started implementing all of the testing. But they did it, you know, kind of after the fact. And then as we were creating new content, we were actually writing the tests as we were writing the code. But tonight, for this example, we will be definitely doing it after the fact. But tonight, when you do your studio, you'll be doing a little bit more like a test-driven development. It's kind of a hybrid. You're going to be trying to write some tests and then fixing the code. Okay, and so this is actually then going to be an int, right? And we said it was 271, yes. So book one we know was set to that, and this is an int. And now it should be able to compare one int against the other. So let's run it again. Yeah, and we're good. Okay, let's keep going. So this one, we want to test that the secondary constructor assigns a value of 0 to num pages. That's what we've set it to do. You may remember, you know, we just call this, so it runs this constructor and we just give it num pages of 0 to allow somebody to instantiate a book without num pages. So that's what we're testing now. And really, we can kind of do the same thing we're doing here, except we're going to use it with book 2. That did not work. I'll try this again. There we go. And I'm going to say second constructor sets num pages to 0. Okay, and so we'll change this to 0, change this to book 2 so that it actually, you know, takes this book 2 that's been instantiated in the before block and without num pages. And then we'll just make sure that it did set it to 0 like it's supposed to. And we're good. All right. So now we're getting into some of the other things. So if you remember last time we came up with this, you know, static integer next ID num that stores a number that you increase every time you create a new book with a new book ID so that the next book will have a different number on the end of it. And this one's a little bit more involved because we don't actually call the generate book ID directly. It's private. It actually just gets called as part of the constructor right here. So we'll just have to, you know, create something to be able to check and make sure that it is actually working the way that it's supposed to. So this is a good example of kind of how sometimes you have to think things through a little bit to decide, you know, what order do you put things in to make sure that it's setting it up for your actual assertion statement. So I'm going to we'll talk about this a little bit at a time here. So I'm going to call it, let's see, test public void, and we'll call it book ID generated, which is, you know, good. All right, and let's say, you know, a book ID is correctly generated using the static field next ID num. This is a much better description than I can provide with just this. So again, this is why I like using the, you know, making a specification to put into the assertion method. And we'll say, you know, we're expecting, okay, so let's think about this. If we're going to use a book we actually are going to need to create a new book. So let's think about this. Let's do this part first. We're going to create a new book because we have to do it as a kind of part of the process of this. And we'll say it's a new book and give it some new information. Let's see, what do I have? I've got, oh yeah. Related, I have a theme going, guys. Secret Life of Bletchley Park. By Sinclair, okay. And it has 322 pages. Okay. Now, I know that, I know now, based on this title name and this author name, you know, and the way that I've set this up, that it's going to generate a book ID that is the initials of the author plus a hyphen, plus the first 3 characters of the title to uppercase, plus a hyphen, plus the next ID number. The only way for me to know what the next ID number is to go get it using the getter. But I can't instantiate the book. If I instantiate the book, it's going to have increased, right? So I need to actually put my expected string first so that I can concatenate it together. And I'm just going to say, I expect it to be SM for the author's initials, and then THE for the first 3 letters of the title. And then I'll concatenate on the book class, because this is a static thing, and say get next ID number to go get it and say, okay, before I instantiate this book, what's that number that's going to be tacked onto it? So I find that out now, then I instantiate the book. And if I were to check the get next ID num after this, of course, it'll be the number after that because it'll have already increased it in the process. And this should give me what I want. And so then I can just say, you know, I expect the actual to be book 3. And this is where I go and get the specific information on the object, you know, get book ID. What is the actual book ID that's resulted after this was instantiated using the previous, you know, previously saved ID number from on a static level. And then I can start it. And, you know, here I can just use my standard spec expected actual. So let's run it. Yeah, and it passes. Does anybody have any questions about that? Because I know that's a little more involved. Hopefully I explained it okay. All right. But yeah, you're going to have times where you're going to have to really kind of think about what order you put things in, and, you know, be a little creative with how you set everything up just so that you can make the assertion. So that's a good example of that. Now, these are going to be much easier. All right, so let's do another test. This one is to test that get title and author correctly concatenates the title and author. That was difficult to say. So I'll do a spec. Oops, I need to actually set it up first, though, don't I? Public void title author concatenated. Okay, and then I can do a spec that's like get title and author correctly concatenates the title and author. It's actually pretty much what I said in the to-do, but ordinarily in practice, you wouldn't have, you know, you wouldn't keep your to-dos around. So for the documentation purposes, you want it here. And then of course it's going to return a string. So expected is going to be, and I can see which, well, let's do book 2. So we'll do Code Girls by Liza Mundy. That would be what we expect to come back. And then the actual is where we call it. So we'll say book 2, get title and author. And that will return whatever it comes back with. And then we can do, you know, oh, for heaven's sake. This was supposed to be like more efficient and it was not. There we go. Okay, assert equals and check it. Okay, and it passed. So, you know, we now can have good confidence that this method, the get title and author method, is doing its job. All right, last ones, checkout method. We want to check a couple of different things about the checkout method. And here again, when you're thinking through, how do I want to design these tests? A lot of times you just go to the source, right? You go to the method. This is the one that I want to test. I want to test this checkout method. What's going on here? Well, there's actually two different things that this accomplishes. One is that it increments times checked out, which is something new that I wrote. Surprise, there's a new field. Okay, right. So this is actually something new. I added this field times checked out so we could kind of keep track of how many times something has been checked out in the past, which means every time it gets checked out, that needs to be checked up. But we also, and you remember this from before, we have this available field that just keeps track of whether something is currently available to be checked out or not. And of course, you have to turn that false if you check a book out. So, and then we'll have a little log, which will actually show up down here. So we'll kind of see that. So we want to check both of these things, and I'm choosing to write them as separate tests because they are kind of independent bits of functionality, even if we are handling them in the same thing. So we'll do the first one and do public void. Let's see, checking out book increases times checked out, that field. Okay, so we'll have a spec string, spec equals book should have been checked out 1 times. That's actually not a very good spec. I wrote that before. I don't like it. Yeah, times checked out is increased by 1 when book is checked out. That's better. So we'll say for expected that we want it to be 1, and that's an int, not a string. Of course, it's a number. Okay, and then so actual will be book 1, and we can say get times checked out, which I put in getters and setters for that. Now there's a problem because I haven't actually checked the book out, right? So this is another one of those things where you act, right? You want to make sure you actually do the thing that's going to generate this. So I will say, book1.checkout to run that and make sure that it gets incremented, and then I can actually go get that value. So how you order things, and it doesn't really matter. Like I could move this up here or down here, and that part doesn't matter. But as long as it's before I go get the actual value, that's all that matters. And then I will have, it's still right there on the clipboard. Okay. And I can run this and check it. Let's do it. Okay, good. So we know that that times checked out field is being increased like it's supposed to be. So now let's check the available field and make sure it's being handled as well. And I'm going to copy this for the sake of time. And so checking out book makes it unavailable. And available is set to false when book is checked out. And then we can say, the Boolean, actually, we don't need to do it this way. We don't need to have an expected and actual because we're going to use a different assertion method. I do need to check out a book, but I can actually just say assert false, and then just say book 1 is available. And I could have put that like out here as like Boolean condition equals book 1 is available. If I want to be like more methodical about this to keep this generic here, we can do it like that too. But essentially, same thing. You can put that specification as the first argument and then just put the condition after it, and it will make it available to the feedback on the test. Let's run it. Okay, good. So both of those things are happening the way that they're supposed to. So with check-in, we want to make sure that it's changing is available to true. And so we'll actually check the book out, change it to false, and then check it back in. And sometimes you have to do that. You have to kind of like line things, kind of set things up in a sequence in order to get what you want out of it. So let's actually, I'm gonna copy this again, I think. And this will say checking in book makes it available. Available set to true when book is checked in. And then I will say, let's do book 2 this time. We'll do book 2.checkout and then book 2.check-in. And then we'll say that, book 2 is available is the condition we're checking. And we want to assert that this is true, not false. Okay. Oh yeah, by the way, when I hover over that, right? I had it a second ago. Okay, hold on. I'll show you what I'm talking about. There we go. When you're typing it in, you can see right there that it's got 2 different constructors, right? The first one is if you just give it the condition, and the second one is you can give the message first and then the condition. So that this is, and we're choosing the second one. So yeah, spec condition, and then it's fine. Yeah, let's run it. All right, that was a lot of tests, y'all, but we, covered this pretty well. Covered a lot of different things that's going on in the book class. So the very last one to do here is library. We are short on time, so let me think about this. All right, I'm going to do a couple of them because they're different, just for the sake of covering a couple more concepts. And then we will, let's see, copy this. I'm going to speed right over these. And then, testing that a newly instantiated library has an empty list of books. So this is interesting. We're creating a couple of books there, giving them some values. We're creating a library, which of course doesn't have anything. It doesn't have a specific constructor. So it's just going to instantiate that books field as an empty array list, but we want to test that. And there's a couple aspects to that we want to test. So I'm going to write a test that's going to public void constructor sets book list. Yeah, and then I'll be more specific in the spec. So string spec. And here I'm going to actually have 2 specs. I'm going to do it all in one test. So not null spec is what I'll call this, just to make sure that it does in fact exist, because we can't really check the size of it unless we're sure that it exists, to make sure it's empty. So I'll say a list of books exists, and then we will assert not null and give it the spec, the not null spec. And then we will just say library.books. We just want to make sure it exists. That's it. And then we can kind of do this second part, which is to say, we want to check the size and make sure it's 0. So size spec would be, a new library has an empty list of books. And so we can say the expected size is going to be 0. And then we can say the actual size will be library.books.size. And then we can just do an assert equals. That gives that size spec, the expected size, and the actual size. Yeah. All right, let's run this. And I need to come up here and run the library. Okay, so yeah, so we can see that it has passed, both of these assertions passed. And I, was able to kind of give them different messages. So if I did get an error message, I would kind of know, which one it was referring to. That's kind of another one of the advantages of this being applied at the assertion method level rather than at the method level, because if you have multiple assertions inside a single method, you'll be able to differentiate. Okay, and then you can test that the book has been added, which let's see, we're running short on time. I'm going to just copy this in and we'll talk about it for a second here. It says, check both that the size is increased and also that the book exists in the list. So here again, I've decided to kind of have a couple sets of these, book list is increased in size. We'll check that first. We get the original size by checking the size before we add a book. We add the book 1. And then we say, okay, the expected size is going to be the original size plus 1. That's what we're expecting, is that it's increased it. And so now we get the actual size and then compare them. And then here we say the book list actually contains the specific book we're looking for. So we're going to set the condition to be, library.books.contains and look for book 1. And if it comes back and, true, then we're in good shape. Okay, and then I had, you may remember I had written this thing, find a book, where we could actually look for a book based on its title and author, and it returns an index. So I'm going to paste these in as well, just run over them real fast. So the first one is, what happens when you have a book that's been added that is definitely there and you expect to see, something greater than -1, 0 or above. So I write the spec, I add the book to the library. I say, I expect now that that's going to be at index 0. Because remember, it's a fresh library every single time because it's in the before block. So no books, and then you add a book and now there is one. And then I say, I test my actual method that I'm trying to test, find a book. I give it the book 1 title, the book 1 author, and then I expect that's going to come back with 0. And when I run it, it does. Similarly, if I, add book 1, but then I actually give it book 2's title and author, I would expect it comes back as -1 because it never found it. So we'll run those. Well, that's, positive case, negative case. And then that custom equals method that we wrote that was very involved. I've got a method, I've got a test for this too. And as you can imagine, this requires quite a sequence of things to set it up. So I wrote my spec, and I'm missing my test annotation here. That's why it's not recognizing it. There we go. Okay. And I added 2 books, and then I made copies of the original books by just creating 2 new books that have the exact same information as the ones that were done in the before block. I created a new library and added the 2 copied books to the copy of the, this new library. And now I'm going to say the condition is library equals library copy. And you may remember from last class, we went through all of that logic about how to test that, where it only tests it based on the title and author, and it ignores, things like the book ID, which are definitely going to be different. And then we just expect it to be true, that those 2 things are equal based on the fact that they both have those 2 books. And so that should return true. Okay, so I hope that helps kind of give you a picture of a lot of the different ways that you can go through and think this through, using different assertion methods, using different sequences of test data and manipulation of the objects that you've created to make sure that your code is running the way that you expect it to. And ideally, you have all those things set up and they just run automatically every time. And then later when you come back and make changes, it'll catch it if you've got something that is no longer working the way it was supposed to. So for Studio tonight, you're going to practice some testing. It won't be as involved as what I just did, but you're going to fork some starter code. Make sure you uncheck that master only because the bonus mission is actually in a different branch. You're going to come up with 12 tests. You have to figure out what they are. And when I demo it for you later. I will show you what I came up with, and then ask you what you came up with that I didn't come up with, because everybody thinks differently. But if you guys work together on this, you should be able to come up with a good list of a bunch of different things. And some of them may cause errors. So, some of them won't, but some of them will, because the code they give you, it works for some cases, but not for others. So you want to think through, what types of things do I need to test that might break this code? And then as those tests are failing because the code is broken, you can fix it. Then if you get to the bonus mission, it's a separate branch. So just use git branch -r to view all the remote branches so you can see it. And then it's bonus_mission. You don't have to do that if you know what it is, but it'll help you see it. And then git checkout, bonus_mission to switch. And then you can work on that part, which is a totally different thing, actually, a binary search algorithm that has an error or two. It has a couple cases it hasn't accounted for, is maybe a better way to say it. So let's look at this. Yeah, they give you very little guidance here on purpose, because they want you to think this through, which is why I went so heavily on process tonight, not just details of syntax and whatnot. So yeah, this bonus mission down here, this binary search, it's, very interesting little problem. So, work together, see if you can figure this out. It'll be fun. I am prepared to code both of those for you tonight. So we'll get through it. So I'll see you guys here at 8 o'clock. And just as a reminder, coming up, can switch back to my slides. Yeah, grade assignment number 1 is due on Monday. We're going to talk about inheritance. And then next Thursday, we'll talk about interfaces and polymorphism. So we're going to, continue kind of digging in deeper and deeper on classes and object-oriented programming. It's going to set you up for doing some really cool stuff in a few classes. So I will see you guys at 8 o'clock.